Okay, so let's start with another exercise on time series. And this is a very important and very useful algorithm which is very commonly used also. So let's first clear all our outputs which are already there, and let us wait for a while. Yeah, it's cleared now. So this is the data set that we are going to use is for the superstore. So for a superstore, and they are selling so many items, but we are only considering 2 items which we'll discuss. And there are several categories of items in the superstore sales data. We start from time series analysis and forecasting for furniture sales. Here we are considering the sale of furniture only. So we are importing all the required libraries like NumPy, Matplotlib, Pandas, then stats model, then Matplotlib also. So all these things are required, so we can import it for our purposes. Then we are also importing our data file which is there in the superstore underscore time series. This is again a XLS, that is Excel file, and then we are transferring it into our data frame known as furniture. So we can do that also. This has been done. This also, let us complete this also. Then we can go for this. Yeah, so this data frame, what our data file has been also accessed, and now that has also gone into this furniture data frame. Now let us check the details of the furniture. So that means just by writing this and clicking on this to run, we can get all that. That means all these columns are available, and then these are the details of that, top 5 rows and top bottom 5 rows also. Total data records are 2121, and 21 columns are there, which you can check here also if you want. So that is how you can get the details, right? The next that we are going to have is, we have a 4-year furniture sales data for our analysis. So we can run that also. Then furniture order date, that is, and min furniture order date maximum, lowest and the highest. So this also we can run and see. It is from 6/1/2014 to 30/12/2017. That's the data that we have. Then data pre-processing. This step includes removing columns we do not need, because there are so many columns which are there, and all these columns we don't need. So whatever we need, only that we should keep in our data frame. So check missing values, aggregate sales by data, and so on. So these are some of the things which we must do for every data set. Then this is the columns, that is row ID, order ID, ship date, ship mode, then customer ID, customer name, segment, and then country, city, state, postal code, region, product ID, category, subcategory, product name, quality, quantity, discount, and profit. So all those things, whatever is there and whatever we need, that only we should keep. Now furniture drops column. Now we are dropping the column also and making it true. So on axis 1, all these columns are going to be dropped. And furniture sort, we are sorting it on order date, and then we are also checking for the null. So all these things are done in just the 3-4 line code, and we can run it. So once we run it, you can get that order date is 0, sales is 0, and data type is integer 64. This pink color, that the background that you are seeing, is just a kind of a warning for us. Nothing is going to be serious about it. Now furniture, again we are going to see that. So furniture dot group by, order date, sales, and sum, reset index. So once we write this code and run it, you can see that it has been done and the data has been shifted to the furniture. Now we are going for indexing with time series. So furniture is equal to furniture dot set index order date, as we have seen earlier, and same thing has been done here. And now furniture index. So once we run this, you can see that you get all that details as per our this is the index date is, and index is order date, right? And it has all been shifted to the furniture. So that's how we keep doing. These are some of the things which we must know, and we must do as and when it is required. Our current date time data can be tricky so to work with. Therefore we will use the averages daily sales value of that month. Instead we are using the start of each month, right? So it depends what logic you want to use. So here we are using this. Now we are going to shift this data to Y, furniture sales, and resample ms dot means. So we can do that, and then when we do Y 2017, then we get the details of only 2017, right from January to December. So 1/1/2017 to 1/12/2017, all those details, and this is our sales value that we got as per this, right? Now visualizing furniture sales time series. Now this is important, because so far we have done whatever for our understanding which is required, we have done that. Now let's see how this how the plot gets created. So we are creating a Y dot plot, fixed size is 15:6, and go for the plot. So when we run it, you see that a good colorful graph is created that shows that how it varies, how it is changing. The different months, you can see the sale is changing. It's not that it is uniform throughout the year. No, it's not that. So that is what we need to understand, and then based on this, as an analyst, one can say, or the concerned person can decide that how we can improve our sale in different months. These are very helpful. Then next is that some distinguishable patterns appear when we plot the data. The time series has seasonality, because seasonality means that in a particular season the sale may go up or go down. All those things do happen, such as sales are always low at the beginning of the year and high at the end of the year. There is always an upward trend within any single year, with a couple of low months in the mid of the year. So these things are practical, and this you can know by your experience, because you are in that particular field. So you know that this happened, but you may not have the exact trend. So that is what it shows. We can also visualize our data using a method called time series. So decomposition that allows us to decompose our time series into 3 distinct components, that is trend, seasonality, and noise. So we can run this. Nothing is going to happen, of course, but then it is for our understanding. Then from PyLab import RC parameter. Now this is again a library available under PyLab, and this PyLab is also one of the libraries available for the Python. So RC parameters, figure fixed size is 18,8. Decomposition, that means SM, TSA, time series analysis, seasonal decomposition, and model is additive. Fig decomposition dot plot, and then we are going to plot that graph also. So we can see that after completing it, that different colors, different types of graphs are created. So you can see that this is for the trend, seasonality, and I think it is for the different sales for the month. And then these are for different months in a particular year. So that's how you can get a clear picture of the sales. This is the title is sales, and that is how you can get this kind of a graph, which is very, very informative. Then the plot above clearly shows that the sale of the furniture is unstable, along with its obvious seasonality. So that is what we can see, and we know it also, but then we want to see the trend. That is the purpose. So we are going to apply one of the most commonly used method of time series forecasting, known as ARIMA. ARIMA is auto-regressive integrated moving averages, which stands for the same thing, that is auto-regressive integrated moving average. ARIMA models are denoted with the notation ARIMA and then small p, d, and q. These 3 parameters account for seasonality, trend, and noise. So it is represented with p, d, and q. So we can run this and see. Then we are going to write the code for creating a kind of plot, and we can see that p is equal to d is equal to q, range is 0 to 2, then pdq, list is equal to intertools. Intertool is again a library which we have imported earlier, and then product PDQ, that is again as is mentioned here, that is trend, seasonality, trend and noise. So that all these three are taken here, and then print examples of parameter combination for seasonal arima, and print same seasonal Arimax, right, for this PDQ, then seasonal PDQ for one, then again the same for a second period, and then for the third period and the fourth. So the same code is being repeated, only the periods is different, that is 1 2 3 4, that's it. So when we run this, you will see that how this is, how you get this kind of a output. That example of the various combinations are available, that is Serimax, that is seasonal, and then auto regressive integrated model moving averages, then 001 001 12, etc., that you are going to get for all these four, right. Then this step is parameter selection for our furniture sales arima time series model. Our goal here is to use a grid search to find the optimal set of parameters that yields the best performance of our model. So we can run this, nothing will happen here, but then this code is important, because for parameter in PDQ that we have already discussed earlier, for parameter seasonal, in seasonal underscore PDQ, try model SM TSA state pace Serimax Y order parameter seasonal order. These are various things which are already available, but we want to bring it into our working. So say enforce stationarity, which is false, enforce invertibility, that is also false, and then results are going to be model fit, and print arima, right, and then X12, then AIC format parameter seasonal results AIC, and then accept continue. So this code is something which is very very important, and you must repeat it a few times so that you can understand clearly as to how this works, and one can then run it, and you can see that it gives you both the results and of course the warning. And you can see that something similar to which we have seen also earlier, that kind of a output is available to us for this, with this kind of a code that has been written here. Now the next is that we are going to the above output suggests that the Serimax 1111, sorry, is still going on, I think. Yeah, so we can see that the above output suggests that Serimax 111 by 111012 yields the lowest AIC value of 297.78. Therefore we should consider this to be optimal option, right. Now fitting the ARIMA model, now we have whatever model that we have created, now we have to fit it. So again writing that model is equal to SM TSA state space Serimax, and then order seasonal and force stationary, and for the same code that we have written earlier. Results is model fit, print results summary tables. So we can run this, and of course you are not going to get much detail, but yes, this table is available so that we can try and understand that with the help of this. You can see that coefficient is standard error Z, and then say P is greater than Z, 0.25 and 0.975, right. Now let us run model diagnosis to investigate any unusual behavior. So once we run this, of course this is a remark, so nothing will happen, but we are going to have a kind of a plot here with the help of this. So results plot, diagnosis, figure size is 16:8, and then plot show. So you can see that different types of graphs are now getting printed here, and standard residual is this, histogram plus estimated density is this, and then a kind of a scatter plot is here, and then a correlogram is here, right. So all these four are coming in one frame, and that is with the help of this results. And for this we have already done some exercise here, So this helps us in getting, and after writing this code, we are getting this kind of a graph, which is very much easy for to interpret. This is the seasonal variation, this is the way it is progressing, this is the linear regression kind, and this again is a parallelogram, how it is related. Now it is not perfect, however, our model diagnostics suggests that the model residuals are closely normally distributed, right? So this again is a remark, that is what for our purpose of understanding. Then predict results get predictions start PD dot to date time, period to date time, that is 2017-11 dynamic false. Predict CI, predict cont int, then axis Y 2014, plot label observed, predicted mean, plot AX, that is the axis that you are going to use, label one step ahead of forecast, alpha is 0.7, figure size is 14.7, then AX fill between, predict CI index, predict CI I lock, then predict CI I lock. Here it is taken 0, here it is taken 1, and color is going to be K, and alpha is going to be 0.2. So axis set is equal to X label date, axis set Y label is furniture sales, and plot is legend, plot is show. So now with this code you are going to get again a kind of a graph, and we can see that how useful it is, how this is the kind of a forecast that you are going to get. So this is the graph that you have already get, and this is the observed one, and this is one step ahead forecast. So you are forecasting, the orange color graph that you are seeing, that it is forecasting. So that is how you can say that from 2014 to 2017 this is the kind of a trend, and then for further beyond that it is going to be something like this. So validating forecast, to help us understand the accuracy of our forecast, we compare predicted sales to real sales of the time series, and we set forecast to start at by 1/1/2017 to the end of the data, right? So that is how we can do that. This again is for our understanding. Then the line plot is showing the observed values compared to the rolling forecast predictions. Overall our forecast align with the true values very well, showing an upward trend. Start with the beginning of the year and captured and seasonality toward the end of the year. So this again is for our understanding. Then we are going to forecast, that is Y forecasted, predicted mean, Y truth is equal to 2017, that is the value that is being given. Then MSE, Y forecasted, Y truth, mean, and then print the mean squared error of our forecast in this format, right? So this is how we can get this. So the mean squared error of our forecast is 22993.56. This is again for our information. And then the root mean squared error of the forecast is like this, we can write, and this will print that error also, RMSE, that is root mean square error of our forecast is 151.64. So you can say that in statistics the mean squared error of an estimator measures the average of the squares of the errors, that is the average squared difference between the estimated values and what is estimated. The MSE is a measure of the quality of an estimator. It is always non-negative, and the smallest the MSE, the closer we are to finding the line of the best fit. Root mean squared error tells us that our model was able to forecast and the average daily furniture sales in the test set within 151.64, because that is the value that we have got, the error, that is root mean squared error of the real sales. Our furniture daily sales figure from around 400 to over 1200 in my opinion, this is pretty good model for so far, right? So again we can, because this comes with experience, and definitely whatever output that you get, you can definitely infer accordingly. Then producing the visualization forecast, that is pred UC results get forecast steps is equal to 100, and pred CI pred UC dot conf in int, and then AX Y plot observed fixed size 14.7, then predicted mean plot AX is equal to X, label forecast, AX is equal to fill between predict CI index and then predict iLock 0 and iLock 1. There's a similar kind of a code that we have written earlier also, if you remember. You can go back and check. AX dot set X label date, AX Y label is furniture sales, plot legend and plot show. So you can see another good looking graph that will be available, and you can definitely try and understand that also. So we can run this and see how it is going to give you this kind of a trend. So you see, so from the same data set now you are getting the and observed and the forecast. So this is the forecast for the next few months up to 25, in fact couple of years from 2017 to 2025, right? So this is how the forecast can be made. Now it is very important that you must read these and try and understand again and again, go through again and again, try as many times as you require, and then try and see to relate it that how this graph is created. Now our model clearly captured furniture sales seasonality, as we can see in this graph also. As we forecast further out into this furniture, into this future, it is natural for us to become less confident in our values. This is reflected by the confidence interval generated, right? So by our model which grow larger as we move further into the future. The above time series analysis for future for furniture makes me curious about other. So categories and how do they compare with each other over time. Therefore, we are going to compare the series of the furniture and office suppliers. Now that is another way to check whether the sale of office supplies are better or the furniture is better. That also can be seen. So we can run this also. This is done. So we can see with nothing of course will happen here. This is also a remark. According to our data, there were many number of sales from office supplies and then from the furniture over the years. So we can run this also. Now we are going to see that furniture DF lock DF category. Now we are going to have a comparison between furniture and office supplies, and furniture shape and office supplies. So here we are, no graph will be prepared, but yes, you are getting the output like this 2121 comma 21, and then this is the two different. Now we are going to go for the data exploration. We are going to compare two categories sales in the same time period. This means combine two data frames into one and plot these two categories for the time series into one plot. So now we are going to, after running this of course nothing will happen, but with this code you will see that it is, and this code is also very important. So we are having the columns like row ID, order ID, ship date, all those columns which we have seen earlier. Then furniture, after dropping the columns also, that also we have done. Office, from office also we have dropped some columns, that is as mentioned here. Then furniture is equal to furniture sort values, we are sorting on date. Office also we are sorting on order date. Then furniture grouping, it will be with the furniture group by. All these codes are simple, I mean simple to understand. Only thing that you have to understand that what is the sequence that we have to use it here. So furniture group by order date sales dot sum and index, reset index. Then office group by again order date sales sum reset index. Furniture set index order date. Office set index. Then Y furniture is equal to furniture sales and resample MS mean. Then Y office sales resample MS mean. Then furniture, if you want you can break into 2 or 3, that's not a problem, because it will do up to that and then it will go to the next. That also is possible, but it is better if you write in one cell only. Then we are going to store into this head. So this is all computation that we are getting it done. That is why I said that if you want you can break it into 2 or 3 cells also. So whatever way it is required. Then store furniture merge office how inner and order on order date. Then store rename columns, sales X, furniture sales Y, right? And this here also we are doing renaming something, and then we are storing in the this particular variable, that is store. We can run this and you can see that this is the we are going, because we have done this store head, so that is why we are getting this 5 top rows of both furniture sales and office sales, right? So we have got this for our understanding, for our satisfaction, that yes, this computation has been done correctly, right? Then now we are going to plot our graph. So PLT figure, fixed size 20, 10, plot is store, the data that we have created in store, order date, then store furniture sales, and then B is of course the parameter, label is furniture, plot PLT plot, then order date of office sales. Again, now earlier we had furniture, now we are having office sales, and label is equal to office supplies. Now X label we have date, Y label we have sales, then PLT title, sales of the furniture and office supplies. So this is a kind of a comparative study that we are going to have, and PLT legend also we are going to have. So once we run it, you will see that you are getting a very good looking graph, and for both the furniture as well as the office supplies. You can see that the legend has been created. Blue is the furniture sale and orange is the office supplies. Title that you've got as sales of furniture and office supplies. And on Y axis you have got the sales, on X axis you have got the date. So this clearly shows you what is the pattern of your sales of two different categories of item, that is furniture and office supplies. Now the next is that now we can conclude it. We observe that sales of furniture and office supplies share a similar seasonal patterns. You can see this here, right? And early of the year is the off season for both of the two categories. It seems the summertime is quiet for office supplies too. In addition, average daily sales for furniture are higher than those of the office supplies. So this is all visible in the graph itself. I mean, you need not look into the table or any other output. Just by looking at the graph, you can easily understand that what is the pattern of sale of different kind of categories of items. It is understandable as the value of furniture should be much higher than those of the office supplies. Occasionally, office supplies passed furniture on average daily sales. Let's find out when was the first time office supply sales surpassed those of the furniture. So that also, if you want, you can check in this particular graph. So all these things are so easy once you get this kind of a graph. Of course, for getting this kind of a graph, you have to do this much. I mean, all that whatever we have done earlier. So this completes our time series analysis for a superstore having two categories of items, that is office supplies and furniture. So this completes this tutorial. Thank you.